We're going to look at a second example where we're asked to determine if the dose is appropriate and how much we should administer. So we have a med label. Looking at the label, I see that the medication is in tablets. So it says each tablet contains 4 milligrams of this medication. I see the total daily dosage for pediatric patients can be calculated on the basis of body area using approximately 8 milligrams per square meter. And so that word approximately is going to come into play, 8 milligrams per square meter. And it says it here in the notation. The word approximately is used with this med because the med comes in tablet form. When we're dealing with a tablet, we cannot be as precise in the amount that we give to our patient. So as where I can measure 1.3 milliliters, I can actually measure 1.3 tablets. I see as I continue reading the usual dose is a half tablet. So that gives me the indication that these tablets could be split into halves. So I'm going to have to round to my nearest feasible dose and keep in mind that instead of having an exact amount, I'm looking for something that is approximately the same. So my actual question, a dose of 4 milligrams per day is ordered for a 4-year-old child whose BSA is 0.69 meters squared, and we're asked if that's appropriate, and if so, how much do we administer? So to figure out if it's appropriate, I have to use what is normally ordered, and so it tells us that the correct amount would be 8 milligrams per meter squared. We're given in the problem the child's BSA is 0.69 meters squared. And I set that up so that the meters squared cancels. Go to my calculator and do the math, and I come up with 5.52, and that is milligrams. So this is the amount that should be given. This right here, the 4 milligrams per day, is what's actually ordered, and it is significantly lower than the 5.52. So looking at the question, is the ordered dose appropriate? The answer is no, and the order is too low. And then it says, if so, how much should you administer? Well, it's not appropriate, so I'm not going to administer anything I should not administer. I do want to address this question, though. If we had come up with an answer of yes, when we figure out how much to administer, we base that on the order. So we're not supposed to administer. If we were, we would take the order of 4 milligrams, and then we would use the tablet strength, that there's 4 milligrams to 1 tablet. Milligrams would cancel, and we'd get an answer of 1 tablet. That's based on the order, but we should not be administering this because it is too low of a dose. If we went and tried to calculate what we should give based on the label, we would start with an ordered amount of 5.52 milligrams, putting it over 1. We know that 1 tablet is the same as 4 milligrams. So milligrams would cancel. We'd do the math on that, and I would get 1.38 tablets. Now that's not feasible because I can't split tablets into 0.38. So that would be approximately 1.5 tablets. That's what the label says we should give. But we have to remember the doctor has not ordered that. So even though that's what we calculated, again, I'm going to cross that out because I shouldn't administer it. The doctor has not ordered it. So because I've calculated that this is not appropriate, I should not administer. I should not administer the order. It's wrong. I should not administer what I calculated because it is not ordered. So I have to go back and I have to talk to the doctor.